Question 1 is a very common type of question where we have two rational terms on the left and one single term on the right. This gives a hint that we have to merge these two rational parts. And how can we merge? By finding their LCM. The LCM will be 1 minus cos theta and 1 plus cos theta. That means we have to multiply this by 1 plus cos theta here, up and down. And we have to multiply 1 minus cos theta, up and down. Since the denominators are same now, just focus on the numerators. So the numerator of the first one will be 1 plus cos theta. There's a plus in between and 1 minus cos theta. We can see that cos theta and cos theta may cancel, so we are left with what, 2 over, if I multiply these two, it will be 1 minus cos square theta. I hope you know the identity. A plus b multiplied by a minus b equal to a square minus b square. So this one is actually 1 square, which is 1, minus b square. Cos theta is b, so cos square. So that's why it is 1 minus cos square. And we know 1 minus cos square is same as sine square theta. And reciprocal of sine square is cosecant square. So we can write this as 2 cosecant square theta, and that was the right hand side. That's what we needed to prove. Okay, let's proceed to question number 2, which is talking about logs. Here we have to express these three terms as a single logarithm. So two of them are already logarithm, but third one is not. Let's convert that to logarithm first. Let's assume that 3 is equal to log c. All right. So when we have log and there is no base written, that means the base is 10. So we can write it as c as 10 to the power 3. C is 1000. So basically this one can be written as minus log 1000. And there are two already with us, so let's write them as they are. Log A plus 3 log B and minus log 1000. But the problem here is we can combine logs only if there is no coefficient. So let's remove this 3 by using logarithmic law. What will happen? That log A remains log A, but this 3 becomes the exponent of its content. So B was the log, so 3 became its exponent minus log 1000. And now we can merge all of them because there is no coefficient in front of any one, so it will be 1 log, which is A multiplied by B cube, because they are adding. Inside log they multiply. This is subtracting, so it will be dividing, and this is one single log. Number 3 is about sets, which is not there anymore, so we will skip it. Let's go to question number 4. Here they're asking us to solve this equation, and in every such equation you will find there is something common between these bases 16 and 8. This 16 can be expressed as an exponent of 2 to the power 4 is 16, and so the power will be 3x minus 2. 8 can be written as 2 cube and its exponent is 2x. So now we can merge this 4 and its exponent and 3 and the exponent over it. Whenever there's an exponent and a further an exponent, they multiply. So we can write this as 2 to the power 4 times 3x minus 2 equal to 2 to the power 3 to the power 2x, and they multiply. Alright, since the bases are same, equate exponents. We can do that. Equate exponents. So that means 4 3x minus 2 is equal to 3 2x, and it becomes 12x minus 8 equal to 6x. So 12x minus 6x equal to 8, 6x equal to 8, and that gives us x equal to 8 over 6, and if we simplify that it becomes 4 over 3. We solve the equation. Given that this can be expressed as a to the power p and b to the power q, find the values of p and q. Alright, so let's simplify. This is square root. We know that this can be written as a to the power 4 third times b to the power minus 2 fifth and to the power half. Square root is same as power half, and that I will explain here now. I will expand this part. A to the power 4 third multiplied by half, because this half multiplies with both of them because they are multiplying. Just keep in mind that is possible only if they are multiplying. If they are adding or subtracting, we can't do this. So next will be b to the power minus 2 fifth times 1 half again, divided by a to the power minus 1 third, no change, b to the power 3 fifth, no change. So it becomes a to the power what? 4 over 6, which can be simplified, but I'm not doing it for the time being. And minus, because there is a down there also, same base with different exponents, so exponents subtract. So I will subtract 1 third from it. So because of subtraction, there will be two negatives. One was with 1 third already and one because of the division. Similarly, b, and this becomes, okay, we can cancel 2 and 2, minus 1 fifth minus 3 fifth. Okay, this is also dividing, so we can subtract exponents. All right, so a 4 sixth, let's simplify this because we want same denominator, right? So 2 third plus 1 third here, minus 1 fifth minus 3 fifth will become minus 4 fifth. All right, so 2 third plus 1 third is 1, so complete a divided by b to the power 4 fifth. Whenever there's a negative exponent, to make it positive, we just reciprocate it. So what did they ask us? To find p and q. So p is 1 and q is minus 4 fifth. This simplification was not needed because they wanted p and q. Done. Okay, next question please. Okay, number 5. Wow, it has been spoiled already, so we have another available down there, so we will do it here and then we will erase that. On the diagram above, sketch the curve this e between 0 and 180, so this is also available to us. In such questions, what we do, we first identify the axis and maximum and minimum. The number which is standalone becomes axis. That means this one is axis. So the graph will be equally above and below this axis. This is amplitude. So 3 above axis and 3 below axis will be your maximum minimum. So 3 above 1 will be 4. So your maximum point will be here. And 3 below it, which is minus 2, is your minimum. Our graph has to be between maximum and minimum. Now this 2 will give us period. So period is 360 divided by 2. This coefficient. 360 divided by this coefficient gives us the period, which is 180. Perfect, because it is up to 180. So our one cycle will finish in this particular graph only. This is a sine. Sine, basic graph of sine is this. Right? This is 360. We'll just copy this graph here, but in this case it will be 180 because that is the period. So start from the axis, which is 1 in this case, go up to maximum, which is 4, then go to axis again, then the minimum, which is minus 2, and back to axis. And let's join these points. That's the graph of part 1. Okay, what is about part 2? Let's see. We'll have to erase this graph for part 2. Okay, I've erased the previous one for this space. So it is saying in second part that on the diagram above, sketch this absolute part of the same graph. So what we do, let's draw that graph again. Okay, so it started from 1, went to 4, so okay, then at 90 it will come back to axis, then at 135 it will go to the minimum, and then go back to axis. All right, because of the absolute, what will happen that the negative part, let me change the color for the negative part. Okay, this negative, it is starting negative part from here, so this will get reflected and become positive because of the absolute. The one which was positive remains positive, but the one which was negative becomes also positive. So this means this part is not going to stay. So what is the new graph? New graph is starting at the same until it is positive, then it goes to the positive again, and again it is positive. Okay, erased. So this is the graph of absolutes 1 plus sine 2x. Now, what are they saying? Next, write down the number of solutions of this same graph, basically left side of an equation, equal to 1. Where is it equal to 1? So, this is equal to 1 here, 1, 2, 3 here, 4 and 5. At 5 places it is equal to 1. So question is, write down the number of solutions. The number of solutions are 5 when it is equal to 1, or we can draw a line which is y is equal to 1 and see how many times it is intersecting that line, and it is intersecting 5 times, so answers are 5. This is the question number 6, where they say that there is a curve, there are two curves rather, and they are intersecting at point A. Show that the x coordinate of A is 2. So let's substitute this into this, because the y here and y here will be common y, which is this y, right? At point of intersection they are equal. So let's do that. So let me start here. 3 times x square. Yeah, y is equal to x square. So I wrote, in place of this y, I wrote x square equal to minus 2x square plus 20x minus 20. So let's bring everything to the left side. So 3x square plus 2x square will be 5x square minus 20x plus 20 equal to 0. They change their signs because they are moving to the left side. All right, all of them have 5, so let's divide the whole equation by 5 to make it easy. So it becomes x square minus 4x plus 4 equal to 0. And we can see that this is a perfect square. X minus 2 whole square is equal to 0. And we got a square because, can you see, they will never cross again. This is the only point they are crossing. And how I got from this to this is because of the experience, but you can use your calculator. If you use your calculator, put 1 equal to A, minus 4 equal to B, and 4 equal to C, you'll get same answer, x equal to 2. That is the x coordinate of the point A, right? Let's go to the next part of this question, which says what? Show that the gradient of the two curves are equal at A. So what is the gradient of a curve? Gradient of a curve is same as gradient of tangent. And obviously that the tangent to this curve and this curve at this point will be the common tangent for the both. All right. But what can we do? We can just find the gradients of the two at x equal to 2. For that, we'll have to differentiate this one. So in this case, dy over dx comes out to be 2x. So the gradient is same as dy over dx at 2. So we'll put x equal to 2 here. 2 times 2 is 4. This is the gradient of the tangent at A for the first curve, and we should get again 4 for the second curve as well. So let's do it. So this equation here, becomes y equal to minus 2 over 3x square plus 20 over 3x minus 20 over 3. Why divided by 3? Because I removed this 3 and divided it to the other side. Alright, let's find dy over dx in this case. Minus 2 over 3 and x square, its differentiation will be 2x. Plus 20 over 3 and the differentiation of x will be just 1 and differentiation of minus 20 over 3 will be 0, so we'll ignore it, and now in place of this x we'll put 2. So minus 2 over 3 and 2 times 2 is 4 plus 20 over 3 and this is minus 8. Both have denominator 3, so we'll take it 3. So minus 8 plus 20 becomes 12 over 3, which is again 4. So the question here was, show that the gradients of the two curves are equal, and we just showed that both of them are equal, though we know for sure that they will have same tangent at same point. All right, let's move on to part 3 of the same question. Find the equation of the tangent to the curves at A. So what will happen for equation of a tangent? We know the equation is y minus y1 equal to mx minus x1. We know the x coordinate where it is needed, 2. Okay. We don't know y, but I can do what? I can use this, any of the two equations, and this is the easier one. Y equal to x square. So at x equal to 2, it will be 4. So y1 becomes 4. When x is 2 at the same point A, y is 4. And I will use this. Gradient we know now is 4. So this will be equation y minus 4 equal to 4x minus 8. And let's bring this 4 to the other side. So y equal to 4x minus 8 plus 4, which will be minus 4. And that's the equation of the tangent. Question number 7. Points A and B have coordinates minus 2, 15. Okay, let's see. Minus 2, 15 will be somewhere here. Okay. Okay, 3, 5. 3, 5. Let's say 3, 5 is here. It's not necessary to be accurate in this case. The perpendicular to the line AB at the point minus 2, 15. So that means minus 2, 15. This is line AB. And perpendicular here, let's say this one. Okay, crosses y-axis at C. Okay, so this is C. Find the area of the triangle ABC. This was A, this was B, and this is C. So this is the triangle of which we have to find the area. So if we know the coordinates of all three corners, we can find the area easily. The only one left here is that we don't know the coordinates of C. So we need to find the equation of this perpendicular line to find the y coordinate of this particular point C. Okay, so the equation of a line is y minus y1 equal to mx minus x1. Since it is passing through this minus 2, 15, so I can easily say that x1 is minus 2 and y1 is 15. So y equal to m is left. So m is the only one we don't know. Okay, so we know this line is perpendicular to line AB. So let's find the gradient of AB first, which will be y2 minus y1. So y2 is 5, y1 is 15. Divided by x2 minus x1. So it is 5 minus 15 equal to minus 10. And 3 plus 2 is 5, which is minus 2. But the gradient of this line, which is perpendicular to AB, will be negative reciprocal of minus 2, which is 1 over 2. And that's complete. That's the equation of the line perpendicular here. I don't have to simplify this because my aim was to find the y coordinate, and we know the x coordinate is 0 here, so let's put x equal to 0 in this and we'll get it. So y minus 15 equal to half 0 minus plus 2 now. Minus minus will make it plus. And this 2 and 2 cancel out. So y minus 15 equal to 1. And y becomes 1 plus 15, which is 16. That means the y coordinate of this is 16. And now we know the coordinates of all three corners of the triangle ABC. Alright, so to find the area, we have this formula. So we'll write the first coordinate here, minus 2, 15. Then let's write 0, 16. It doesn't matter in triangle which one you write first, which you write second. But once you have maintained the flow, then it has to be the first one will be repeated again. That's what you have to take care. Okay, then first we will multiply these three. So it becomes half absolute. Let's start bracket. So minus 2 times 16 is minus 32. 0 times 5 will be 0. 3 times 15, 45. Minus, we'll go this way this time. 0. 15 times 0 is 0. 16 times 3 is 48. And 5 times minus 2 is minus 10. Okay, so that becomes half. Okay, minus 32 plus 45 is positive 13. Minus 48 minus 10 is 38. So half, and 13 minus 38 will be minus 25, but because of absolute sign it becomes positive 25. Answer is 12.5 units square. That's the answer. Number 9. A body moves in a straight line in such that t seconds after passing through the point O, let me draw it. Okay, this is the point O. So here we will count time is equal to 0 and the distance from this same spot is 0. Alright, its displacement from O s meters and velocity v, and the body of the body is such that v is 5 cos 40. Alright, so v equal to 5 cos 40. Write down the velocity of the body as it passes through O. So at O we know time is 0 and we have to just substitute this t with 0 and we'll find velocity. 5 cos 4 times 0. So which is become 5 cos 0. Cos 0 is 1. So the answer is 5 meters per second. Find the value of t when the acceleration of the body is first equal to 10 meters per second. They're saying first. That is key here. And why, you just know it. So find the value of acceleration, right? So we have v equation. For acceleration, we know it is dv over dt. So the differentiation of this 5 will be untouched, but cos 40, its differentiation will be minus sine 40, and we will differentiate the angle and multiply it here. Please keep in mind this minus is not subtracting, it is multiplying with it. So we will effectively get minus 20 sine 40. And now they said it is equal to 10. So it is equal to 10 and we have to find t. So let's divide both sides by minus 20, minus 20. So it will be sine 40 equal to minus half, because 0 and 0 cancel, so minus half. 40 equal to sine inverse minus half. So since they are saying for the first time, now we will see that sine is negative in these two quadrants. And first time since they are saying, so we will find only the first answer, which is this one. So 40 equal to sine inverse half, without, now we will ignore negative, okay? When we find actual inverse, we ignore negative because negative has given us quadrants. So now negative will not be used. and sine inverse half is pi by 6. Alright, so it becomes pi, this angle is pi, and pi by 6 extra, so pi plus pi by 6. So t becomes 1/4 of pi plus pi by 6, which will be 6 pi plus 7 pi over 6, 1/4 of 7 pi over 6, or 7 pi over 24. Since this is a practical question, we'll give answer in decimals. So 7 pi by 24 in decimal will be 0.916 seconds. Let's go to the third part rather. Find the value of s when t is 5. Okay, the equation we have is v equal to 5 cos 40. Okay, our equation is v equal to 5 cos 40. Now we want s, and s is nothing but integration of v, which is 5 cos 40 dt. So s equal to 5 will remain 5 cos 40. Its integration is sine 40 positive and divide by 4 and plus c. Now we have to find c before we proceed. And to find c, we know that at t equal to 0, s was equal to 0. So we can use this fact to find this. So 0 equal to 5 sine 4 times 0 will be 0 over 4 plus c. Sine 0 is 0. So this whole thing becomes 0. So c is equal to 0. So c is insignificant. But we must show the process that c is equal to 0. So our equation s becomes 5 over 4 sine 4t. C is gone now. Alright. Now they're saying find the value of s when t is 5. So now we'll just put 5 in place of this one. So s equal to 5 over 4 sine 4 times 5, which is 5 over 4 sine 20. Please keep in mind, 4 times 5 is 20. That does not make it degrees. No, it will still be radians. So no degrees. Just put 5 over 4 sine 20 and set your calculator to radians, and that will give you S. In my case, it came out to be 1.14 meters. In question number 10, they have given a curve dy over dx. Its differentiation part is equal to this, where a is a constant. At point 1,4, the gradient of the curve is 2. Find the value of a. So the gradient of the curve is 2 at 1,4. We can use this formula here. Dy over dx is the gradient. So we will substitute it by 2. Equal to a is a, e to the power 1 minus, and x we know is 1. Minus 3, 1 square. So we substituted this here. So 2 equal to a, e to the power 0. E to the power 0 is 1. Anything power 0 is 1. Minus 3. So let's bring this 3 here. It becomes 2 plus 3, 5 equal to a. That's the answer. Okay. Find the equation of the curve. So we know that equation of any curve is in this format, y equal to something. So if we convert dy over dx equal to a, we know now 5 e to the power 1 minus x minus 3x squared, by removing this dx and multiplying it here will be the same thing, and then we can integrate so that dy is integrated to y, and that's what we will do now. Y equal to integration of this. 5 is a constant, untouched. E to the power minus 1 minus x, but we will multiply this further by the differentiation of the exponent, which is minus 1. Differentiation of 1 minus x is minus 1. Now integration of this will be minus 3 remains minus 3, and x 2 plus 1, 3 divided by 3, and plus c. It is very important to have plus c written here. So now we have to find the value of c. Without finding the value of c, the equation of the curve is not complete. And this point 1, 4 will help us to do that. 1, 4. Y is 4, x is 1. Let's do that one. So 4 equal to 5 e to the power 1 minus 1 times minus 1. So I'll put minus 1. This minus 1 as a minus in front. Plus, minus 3 and 3 cancel out. X cube, and x is 1, plus c. And now we can find c easily. So 4 equal to minus 5, because e to the power 0 again will be 1, so minus 5 left. And minus 1 plus c. So they become minus 6, and when they go to the left side, it becomes 4 plus 6 equal to c. So c is equal to 10. And our final equation becomes, we'll substitute c in this equation, y equal to 5 minus 5. E to the power 1 minus x and minus x cube plus c plus 10. This is the equation of the curve. Let's find this. So we have to integrate this. So since 7x plus 8 is a linear, so it is not a big deal. So for integration of such things, we should do what? We should first integrate this whole thing just like a normal x to the power something. So it will be 7x plus 8, 1 over 3 plus 1 divided by 1 over 3 plus 1. Okay, but further we must divide it by the differentiation of what is inside the bracket. And differentiation of 7x plus 8 is 7. So I'm not writing divided by 7 here, I'm writing multiplied by 1 over 7, so that cleanliness of this thing is maintained. So 7x plus 8 to the power 4 third over 4 and third multiplied by 1/7. So the answer should be 3 over 28. 7x plus 8 to the power 4 third and plus c. We did not write plus c earlier. So finally we will add plus c. Okay, c part is there. Alright. Hence evaluate this. Oh, it's from 0 to 8 and exactly same, right? Yeah, it is exactly same. That means we have to evaluate the same answer, which is this 3 over 28. Let's keep it out. Okay, 7x plus 8 to the power 4 over 3 plus c, and from 0 to 8. Okay, so that will be 3 over 28. Substitute by 8 first. 7 times 8 plus 8 to the power 4 third. C will get cancelled out, so let's ignore it. Minus 7 times 0 plus 8 to the power 4 third. Okay, 3 over 28. This is 56. 7 times 8, 56, plus 8 is 64. And 1/3 of 64 will be 4, and 4 will be 256. Okay, I did it mentally. You can use calculator, please. So minus 7 times 0 is 0. So e to the power 4 third will be 2 to the power 16. So it will be 3 over 28 times 240, which will be, okay, we can cancel this. 7, 60. So 180 over 7, or if we divide it, 25.7. That's the answer. Question 11, there's given a function. Okay, they are saying that show that function can also be converted to this, and we can see this is completing square method. So one of the easiest way I find is this. I have shown at least 5 ways to find vertex of a graph, quadratic graph that is, and I will give link to that particular video at the description of this video. And the easiest one I found out of those 5 methods is this one. What do? We open x plus a square, this one thing first. So it will be x square plus a square plus 2ax plus b. I expanded x plus a whole square, a square plus b square plus 2ab, that's what it is. So let's open it now. 2x square plus 2 is a square plus 4ax plus b. Let's compare it with the equation they have given. 2x square minus 8x plus 5 equal to 0. Can you see 2x square and 2x square are matching perfectly? The coefficient of x is minus 8. So let's compare the coefficient of x, minus 8 on the left side and 4a in the right side. So a comes out to be minus 8 divided by 4 minus 2. We got a. Let's compare the constant part. Constant here is 5. Constants here are 2a square plus b. So 5 is a is already known to us, minus 2. So 2 times minus 2 square plus b. Minus 2 square will be 4 times 2 is 8. So 5 minus 8 is b, which is minus 3. So we got a equal to minus 2, b equal to minus 3. That's it. This was the easiest one. Let's go to the next one. Hence or otherwise, write down the suitable domain for f so that f inverse x exists. So let's rewrite the previous question we got when we converted it. Here it is. So let's write it. 2 plus 2, let's write fx also. 2x plus a is minus 2 square plus b minus 3. So whenever we have this format, the negative of this big point, this particular number becomes the x coordinate of the vertex, which is positive 2, and this is the y coordinate, which is minus 3. So what it means that the graph is opening up because the leading coefficient is positive here. So the graph will look like something like this. 2 minus 3. 2 minus 3 will be somewhere here. So 2 minus 3. Right? So now they are asking in B part to find the domain of f so that f inverse exists. In this case, the f inverse is not existing because it is 2 to 1. Two x's are having same y. So if we want f inverse to exist, that means we will have to erase half of this particular graph. Let's erase this one. Okay, this is suitable. We could have erased the right one also, but I am erasing the left one. So in marking scheme, I am sure both of the answers will be there. So domain for f becomes anything more than 2. This x coordinate is 2 at this vertex. So x is greater than 2, and this becomes the domain for which the f inverse exists. If you erase this part, so in that case it will be x is less than equal to 2. I should have put equal here as well. So x is less than equal to 2 is also correct answer. Both of them should be acceptable. It depends on which part you are erasing. Alright, the next one. The function g and h are defined by these, so they have nothing to do with the first part. Gx is this, hx is this, both x are greater than 0. That means there is no negative value. Write down the range of g and h inverse. So let's find the range of x square plus 4 first. Okay, x square plus 4. It is y equal to x square is a graph like this, right? Plus 4 means this graph has gone up. Every part of this has gone up by 4 points, 4 units up. This is 4. So the vertex of this particular new graph, x square plus 4, is 0, 4. So the range of g, so range of g becomes y is always greater than or equal to 4 because there is no value below this number. The whole graph is above this. That's why that is the range. Now, range of H inverse, right? That's what they're asking. So range, keep in mind, range of inverse is same as domain of main function. Okay, so let's find the domain of this. Rather, why should we find? They have given x is greater than 0. So the range of H inverse will be y is greater than equal to 0. Whatever is domain given for H will be the range of its inverse. Both of them are y's. You can write them by their actual value. Here in this case, it was the domain of gx. So gx is greater than equal to 4. Here you can write H inverse x is greater than equal to 0. That is another option. Okay, let's go to the next part. The axis below sketch the graphs of y equal to gx and g inverse x, showing the coordinates of any point where the curves meet coordinate axis. Okay, so gx we already knew, we drew it. Okay, it was something like this. It was a parabola. It was gx equal to x squared plus 4, and this part is 4. Now we want to draw its inverse, and for drawing inverse we should draw a line y equal to x like this. So now to draw its inverse we will just reflect it over this line. So this was 0 4 here, so 4 0 will be the reflection of that point 4 0, and this part, because they have not given any negative part and it has to be a function, so this will be the reflection of each point of this part. This part is ignored because that part is ignored, otherwise it will not be a function. So this is the only graph. In this question they're saying answer only one of the following two alternatives, but we will do both of them. The equation of a curve is this. Okay, find the x coordinate of the stationary point on the curve and determine the nature of each of these stationary points. So let me try to accommodate it here. Dy over dx, the differentiation of this x minus 1 prime x square minus 6x plus 2 plus x minus 1 times x square minus 6x plus 2. Okay, product rule, that is. So this differentiation will be 1 and we'll be left with x square minus 6x plus 2 only. Now plus x minus 1 will be here, and will be differentiation of this will be 2x minus 6. Okay, so now we will simplify this. Okay, x square minus 6x plus 2, x times 2x will be 2x square, x times minus 6 minus 6x minus 2x plus 6. So x square and 2x square become 3x square minus 6x minus 6x minus 2x will be minus 14. X and 2 plus 6 is 8. This is dy over dx. For stationary points we have to make it equal to 0. So let's put this in a calculator and see what x values it gives us. X equal to, so I got 2/3 and 4. Okay, these are the two ones. So first part is done. Find the x coordinate of stationary point. These are the x coordinates, 2/3 and 4. Now we have to find the nature of each of them. So for nature of these 2 points, we have to find second derivatives. D square y over dx square. Second derivative of this one, which will be 6x minus 14. Now plug in 2/3 and 4 one by one into this. Let's put 2/3 first. 6 times 2/3 minus 14. This cancels. 4 minus 14 is minus 10. Minus 10 is negative. Whatever gives you a second derivative as negative, it means it is opening down, and that means it's a maximum. So the nature of the point where x is 2 over 3 is maximum. Repeat this for 4 and definitely you are going to get minimum. Let me do it mentally. 6 times 4 will be 24. 24 minus 14 is plus 10. Plus 10 means it is opening up. It's a minimum for sure. So we got it. So nature is maximum for 2/3, minimum for 4. Alright. Given that z, something else, equal to y square, and z is increasing at a constant rate of 10 units per second, find the rate of change when x is 2, rate of change in y. So first we'll find dz over dy, okay? Z with respect to y will be just 2y, right? So now they're asking what is the rate of change of y if z is changing at 10 units per second. Since there is no second, so we will divide up by dt and divide by dt. So it becomes now per second. So dz over dt is given as 10 units per second. So 10 divided by dy over dt equal to 2y. Y is where x is 2. Okay. So it is related with the previous one. Wow. So let's put here 2 in place of this. So 2 minus 1 is 1. 2 square is 4 minus 6 times 2 is 12 plus 2. So it becomes 4 minus 12 is minus 8 plus 2 is minus 6. So y is minus 6 when x is 2. So that means we will put here dy over dt, oh sorry, 2 times y, it was right, minus 6. So cross multiply, not here, dy over dt will come to the right side, and here we'll be left with 10 divided by minus 12. So minus 12 comes down, dy over dt goes up. So answer is 5 over 6, negative 5 over 6. So since the rate of change of z is increasing at 10 units per second, the y is decreasing because it's negative at 5 over 6 units per second. It became too clumsy here, but it's okay. I hope I have explained it very slowly so you might have understood. Hence, find the rate of change in x when x is equal to 2. Wow. So dy over dx was this. Let me write it again. Dy over dx was 3x squared minus 14x plus 8, right? Now, we will again put divided by dt here, divided by dt here. So dy over dt we just found out minus 5 over 6. So here we will write minus 5 over 6 in place of dy over dt. Let me spoil this next part also and I will erase this later. So minus 5 over 6 divided by dx over dt equal to 3x square. X is 2. They have given 2. So 3x square minus 14x plus 8. So this will be 12 minus 28 minus 16 plus 8 minus 8. So minus 5 over 6 equal to minus 8, and dx over dt I'll go and multiply with minus 8. So now minus 8 can multiply here. So it becomes minus 5 over minus 48, which is dx over dt, and this is, for both are positive, so 5 over 48 per second is the rate at which x is increasing, okay, because it's positive. Okay, I have cleaned it for the second part. Now, they say the diagram shows a cuboid and they have given its dimensions. Show that the surface area of the cuboid is given by this. Is it closed or open? Okay, so it is closed. So we know the surface area of any cuboid is 2 length times breadth plus breadth times height plus length times height, and that's what we will do. A, because they are representing surface area by A, so we will write A. 2 times length, length is 2x, times breadth, which is x, plus breadth, which is x, times y, which is height, plus length, and height is y. Done. Let's simplify this. A equal to 2 times 2x square plus 3xy. To xy plus xy will become 3xy. And if we open the bracket, A becomes 4x square plus 6xy, and this is not matching with what we want. That means we have to get rid of this y. Let's get rid of. So let's write an equation which will be relating x and y, and they have given here. The volume is 72 centimeter cube. So volume of a cube, or cuboid rather, is L times B times H. Alright, so volume is 72, L is 2x, breadth is x, and height is y. So we want to eliminate y, so we'll isolate y here. 72 divided by 2x square, and this is what we'll do here now, equal to 4x square plus 6x times y. Y is now 72 over 2x square. One of these x's will cancel with this, and we get this expression. Done. Given that x can vary, find the dimension of the cuboid when A is minimum. Minimum means stationary point they are talking about. So let's find dA over dx. Okay, because A is minimum, that means we have to find the minimum point of dA over dx. So let's differentiate this. So differentiation of 4x square is 8x, and differentiation of 216, write it as 216x to the power minus 1. So it will be minus 216x to the power minus 2, or 8x minus 216 over x square. This has to be equal to 0 for minimum or maximum. So let's bring 216 to the other side, becomes positive. Since we want x, so we'll multiply this 8x with here. So 8x cube equal to 216. X cube equal to 216 over 8 cube root both sides. So cube root of 216 is 6, cube root of 8 is 2, and that is 3 centimeters. X is 3 centimeters. So they're saying find the dimensions. So now we will substitute everything here. So length was 2x, x is 3. So 2 times 3, 6 centimeters. Breadth, which was just x, 3 centimeters. Height, okay, equal to y, and y was, we got y already, 72 divided by 2x square. So it becomes 72 over 2x square. So 3 square is 9, times 2 is 18. So 18 times 4 is 72. It is 4 centimeter. We got the height, we got the length, we got the breadth, everything is known to us. Alright, given that x increases from 2 to 2 plus p. Okay, so that means x is 2 and delta x is p. P is the change in x. Okay, find in terms of p the corresponding approximate change in a. So this dA over dx for small change will become delta a over delta x equal to 8x minus 216 x to the power minus 2. So let's plug in the values, and we get delta a and over p, delta x is p, right, equal to 8 times 2, 16, minus 216 2 to the power, okay, 216 divided by 2 square is 4. Alright, that comes out to be 4 times 5 is 20 and 16, 54. Okay, 16 minus 54 is minus 38, and this p will go and multiply with this, cross multiply 38p.